Good afternoon, everyone. My name is Moinak Mojumdar, and I am from the Institute for Industrial IT from Lemgo, Germany. So, currently, we are working on a national level project called the Future Industrial Network Architecture, or in short, FIND. So, in this project, we dealt with the heterogeneity issue of industrial networks and how management of such kind of networks can be achieved through the state of the art networking technologies. So this work in progress paper is part of this FIND project, and here we propose a semantic knowledge base as a solution to this heterogeneity problem. The reference architecture model for Industry 4.0 proposes the idea of connected factories, which means the communication can be expected to happen among various domains of the automation pyramid, as well as beyond the boundary of the factory and over the internet. So here in this figure, we have an example heterogeneous industrial network with defined networks connected to each other through a backbone network. And there is a possibility to communicate over the web. For example, uploading some data to a cloud platform for analytical purpose or access to some certain device in the shop floor for remote maintenance. So in a network such as this, there can be multiple use case scenarios. For example, priority of a certain network traffic coming from a sensor device can change over time due to there some changes in the environment, or scheduling traffic between two defined networks on a timely basis for updating data which requires higher bandwidth for a certain period of time. So these kind of scenarios require an on-the-fly configuration of the network based on the requirements of these industrial applications running in the network, which means the entity which is responsible for configuration of the network should possess the knowledge of this underlying network. So the idea here is to introduce certain centralized intelligence into the network, which should be able to monitor the network in real time and perform on the fly configuration if necessary. The concept in our FIND project is to develop such kind of network controller which should be able to perform the management of a heterogeneous industrial network. So I will not go into the details of the FIND controller concept because there is another presentation for that. Just to give you some basic idea, the picture here shows the concept of central network controller. The idea is that the application requirements will be provided to the network controller in a technology agnostic data format, and based on the network knowledge it has, it should be able to map these application requirements to the physical resources. The primary concern here is the separation between the control and the forwarding plane, similar to the SDN paradigm, and modeling the entities of the underlying network using standardized modeling framework and provide that knowledge to the controller. The controller should use interface function, which should be language or technology independent, to collect data from the network as well as perform some certain tasks, for example, discovering the network or controller monitoring the network. So the UML diagram shown here describes the meta model of the network. The idea is to model all the entities present in the network in a generic way. So the diagram is separated actually into two parts for better understanding. The base of the lower layer shows the modeling of physical entities, for example, devices or ports in the devices or links. And on top, it shows the logical entities which are modeled based on these physical entities. The upper layer diagram shows some of the logical entities, for example, network slices or how the categorization is done for logical devices based on their types. And on top of it, it shows the automation functions and communication functions that are mapped to these logical devices. So this meta model acts as a primary version, and the next step would be to implement this model inside the FIND controller. So to sum up the paper, we describe certain Industry 4.0 use cases and describe the need for developing a knowledge base of the network. The concept of a centralized network controller is also introduced in this paper, which can use this knowledge base for network management. Apart from that, this paper also proposes a semantic meta model for the description of the network entities in order to develop this network knowledge base. So thank you for your attention. And now if you have any question, you can just ask me.